Hey guys, this is a walkthrough of your study guide on Alex. So you have the option of doing quizzes. Some kids prefer that. Some kids absolutely hate quizzes. So I'm giving the option of doing either or. You just have to let me know, like at the beginning of class, which one you prefer, so I know where to keep an eye out for your scores. Okay. So your study guide on Alex is 17 questions total. You notice, just like always, I give you 2 attempts. Okay. So please make sure that you are trying your best and putting in all the attempts you possibly can. Okay. So I'm just going to walk you through this so you have an idea of what each question is like. You can play this along as you are doing your problems. That way you get a little bit of guidance, whether you're still in the classroom with me, you're doing this in extension, or at home to practice. Okay. So the first few questions you're going to get on your test have to do with your basics, right? Do you know all the different ways that you can write a ratio? That's like absolute first lesson of the unit, right? So there are 3 different ways that you can write a ratio. You can make it look like a fraction. Most people avoid that. You can also take that same ratio of 1 to 9 and use those colons, right? The little snake bites to compare 1 to 9. Notice I'm keeping the numbers in the exact same order, right? The other way of doing it is actually using your words, right? That's literally how I just read it. And that is bothering me because apparently you have to like click on the box. Okay. The other one is 1 to 9. Okay. So 1 to 9, 1 to 9, 1 to 9, right? Fraction, colon, and the word. Okay. So that is on your test. You can try another even when you get them correct. I do love that because sometimes you get them correct, but you're like, I'm still not super confident. So on this practice, you can keep going. Okay. You can ask for another one if you want more practice. The next part of it is I think on your actual unit test, I give you a visual to go along with it. So there would actually be pictures of flowers on your test or whatever. So on this one, there are 8 roses in a vase of 11 flowers. The rest are daisies. Okay, so you have 11 flowers in a vase, 8 are roses, and the rest are daisies. So how many are daisies, you guys? All you're doing is finding the difference between 11 and 8, correct? So you have 3 daisies. You kind of need to keep that in mind off to the side of your head, okay? So what is the ratio of daisies to all flowers? So I just determined that there are 3 daisies. Yeah. I'm going to use my little format. There are 3 daisies, and the total number of flowers is 11. Cool. And then what's the ratio of daisies? Remember, we determined that there are 3. So the ratio of daisies to roses. Well, there are 3 daisies, and how many roses? 8 roses. Okay. So part of it, you kind of have to do your own little equation, and then the rest is right there in your problem. Okay. Again, if you want to try another one, you can, or you can keep going. The purpose of this study guide is to have you practice things so you feel confident. It's not a checklist. So just because you get it done, you're like, whew, now it's off my to-do list. If you're still lost, like it defeated the purpose. Okay. So do the ones that you really need to focus on a couple of times. Okay. So the next part of your test is just being able to create equivalent ratios that kind of increase or decrease by the same amount. Okay. So here's an example. For the high school basketball game, it costs $8 for 2 tickets. Okay. Complete the table below showing the cost and the number of tickets. Okay. So if it's $8 for 2, I always tell kids, even if you can't figure out a way to do your ratios up here, I always say it seems to be a little bit easier for me to come up with my unit rate. So if it's $8 for 2, I know that means it's going to be $4 for 1 ticket, right? That's my unit rate. Okay. I figure that out even though it doesn't ask me to because it's going to help me figure out everything else super easy now. So if you watch, so if I have 3 tickets, what would be the cost? Without even having to look anywhere else, I can just look at my unit rate. What if I have 3 tickets instead of 1? Well, if every ticket's $4, and I need 3 of them, I'm just going to take that $4 times 3. So I know that's automatically $12. Cool. Same thing for this one. If I need 9 tickets, I'm just going to multiply that one ticket by 9. So I need to multiply the cost by 9. So I know that 4 times 9 will get me a cost of 36 bucks, right? And then you can kind of go the opposite direction. I say that you can look to see if you have patterns this way, like horizontally from box to box, or you can look up and down. It's up to you, right? I know automatically I can look this way and say, there's a pattern right here. 2 times 4 is 8. Let's see if that works over here. 3 times 4 is 12. 9 times 4 is 36. So my pattern is my number of tickets times 4 will get me my top answer, right? My cost. So what number times 4 gets me 40? What number times 4 gets me 40? 10 times 4 is 40, right? What number times 4 gets me 20? Right? So I have filled out my entire chart. Cool. Again, you don't have to do your unit rate, but it sure is easy. Okay. I feel like it is anyway. Here we go. Next one. Doop, doop. More of these. Christine is driving her motorhome, an RV, right? It uses 3 gallons of gas for every 24 miles. That's insane. So that's like 3 gallons of gas for me to get down to, I think from my house to school, I think is like 20 miles. That's insane. So that would be 3 gallons of gas. I would be so poor. Okay, so I'm going to go through and say once again, right? If it's 3 gallons for 24 miles, how many gallons is that for 1 mile? I like to come up with a unit rate. Do you have to? No, but I like to. So 1 gallon, right? How do you get from 3 to 1? You just divide by 3, right? So what's 24 divided by 3? 8, right? Okay. So that means I can drive 8 miles per gallon. That's crazy. That's hardly anything at all. Okay. So now I can use that information if I want. Unit rates are lovely. They make math so easy. Or you can just go through and try to find the pattern. I'm going to show you either way. Okay. So again, you can just look here and say, okay, this is the information they're giving me. Do I have a pattern that I can notice? 3 times what gets me 24? Times 8, right? So again, if I am finding that my top number times 8 gets me my bottom number, I want to do that for every single one on here. I'm going to continue that pattern. Okay. So my number of gallons needs to be multiplied by 8 to get me my distance. Okay. So 3 times 8 is 24. What's 5 times 8? 40. What's 7 times 8? 56. What times 8 is 64? 8 times 8 is 64. Okay. And then 10 times 8 is 80. Cool. So I can go off the pattern here, or I could go through and just use this and say, if I'm going to drive 7 miles, or if I put 7 gallons in my car, that's times 7 over here, right? Not 1 gallon, but I have 7 gallons instead. So if I multiply this number by 7, I also have to multiply, or sorry, yeah. If I have to multiply this number by 7, then I also have to multiply this number by 7. So that's how you could also get 56. Either way, like I said, everybody's brains work differently, and I've seen you guys go both routes. So I do want to make sure and show you both ways. Cool. So you do have 2 ratio tables on your test, just as a heads up. Cool. Okay. Moving on, these are better buy questions. Okay. So with your better buy question, Sean pays $3.78 for a bag of 14 tangerines. Find the unit price in dollars. So a unit price, meaning how much am I paying, or how much does it cost how much is it going to cost Sean for one tangerine? So I'm setting this up. If you go to your unit rate or your unit price notes, I always say you start with your, please tell me you know this. You always start with your money, 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 money. Okay, start with your money. So I'm going to take the amount of money that Sean is paying, $3.78, and you always divide. Okay, unit prices are division problems. If I'm paying $3.78 for 14 tangerines, if I take that cost and I chop it into 14 pieces, I'll know how much I'm paying per tangerine, right? So you always start with your money and divide by however many things you're buying. I'm buying 14 tangerines. Okay. So 0.27, right? What does that mean in terms of money? That is 27 cents per tangerine. Cool. You're going to notice on some of your unit price questions on the test, you're going to have to round because I want you to know the format of money by now. So if you get a really long decimal, you have to know how to chop that off correctly so it represents an actual money amount. This might be a good example. Let's look at this. So a certain shampoo is available in 2 sizes. This happens a lot. A 14.2 ounce bottle, 14 and 2/10 ounce bottle, costs $3.98. Okay. But if you want to go like huge, which I usually do because I hate grocery shopping, so I'd rather just get it and have it last a long time. A 33.9 ounce bottle, or 33 and 9/10 bottle, costs $9.98. So find your unit price for each size. Figure out which one is actually giving you the better deal. So the lovely, just like on your test and in the real world, you're going to get a calculator, right? You always start with your money, 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 money. So I'm going to start with that $3.98, right? And I'm going to divide by however many things I'm buying. This is not tangerines. I'm buying ounces. So when I divide by however many things I'm buying, I'm going to divide by 14.2 ounces because that's the number of items I'm buying. Okay, fabulous example. This is a really weird decimal, right? I had kids on the mastery check write this down as the cost. I don't even know how you would begin to dig in a purse or a wallet to pay something like that. That's not our format for money, right? So let me go through and just kind of show you this, all right? You don't even really need to write out absolutely everything, but hopefully by now we realize that when you're talking about money, I'm just going to go this far. You only go 2 place values over when it comes to change, right? Like $1.28 or $5.03, whatever. It's 2 place values over. That is it. That's where you have to chop off your decimal for it to stay in the money format. But you don't just chop it off. You have to look next door before you chop it off. That number tells you, am I just going to keep the number as it is, or do I need to round it up? Well, it's 0. So I'm just going to keep it as it is. 0 does not tell me that I'm close to the next number. So when I go to answer over here, I'm actually typing in, it is 28 cents per ounce. Cool? So you get the calculator, but you still have to know what the heck that means, right? So again, that's why we say it's not really cheating. You still have to know money goes in first. You divide by however many things you're buying, and you have to know how to round it. Okay. So the second thing is it's a bigger bottle, right? You're paying $9.98, right? Your money, money, money goes first. And you're dividing that by however many things you're buying. So I'm dividing it by the number of ounces. And again, I get something crazy stupid, right? That is not money format. You only get to go over 2 place values when you're talking about money, and then you have to chop the rest off, right? So this is, I'm not even going to go all the way. Oops, did I write that right? You did. Okay. So you only get to go 2 place values over, but before you just chop it off completely, you have to look next door for your rounding purposes. If it's a 4, you just keep it the same, right? You only round up if this is a 5 or above. So if it's a 5, 6, 7, 8, or 9, you're going to round up. equal, but it's not. So we now know that that equals or means that it's roughly 29 cents per ounce. Okay. And then the last part is kids will get all this and then they're like, which one's the better buy, Miss Newald? Well, what do you want to do? When you go into a store, do you want to pay 28 cents for something or 29 cents for something? You just want to go for whatever's cheaper, right? Is it cheap by much? No. But if you have something that, like, let's say absolutely everything in your cart is cheaper than another option just by a little bit, if you do that all year, you're going to save hundreds of dollars. I know it sounds so weird, but you have to shop smart and that will save you time and money. Okay. So the better buy, the cheaper version is your 14.2 ounce. Okay. Sometimes you will get neither. Okay. Luckily, that's not what we got because I wanted to at least be able to show you. Okay. So again, I am going to clear this. You do have unit prices. If this is something that's not coming really quickly to you, try another one, right? Like I'm saying, this is all for you. So if you're not super confident, try it. The more you do it, the more it'll stick in your head. Okay. The next part of your test is going to be converting, right? Do you have a fraction, a decimal, or a percent, and can you convert it to something else? Okay. So your main skill right now is when you have a percent, what does that mean as a decimal? Okay, there's a couple ways that you can think of it. I always said DP. If you were in my small group, we wrote DP really big in our notes because if they're in alphabetical order, right, to go from a decimal to a percent, you move it to the right. If you're going from a percent to a decimal, you're moving it to the left. Okay. It's always 2 hops. So if you want to say this, we're starting out with 56%, right? Well, remember with any whole number, you have a decimal right here, right? So I'm going from percent to decimal. So I'm going to go to the left 2 hops. Right here. Okay. So that tells me that my answer is 56 hundredths, right? The other way, if you're like, I don't really remember DP, I can always remember percents are out of 100, right? So this literally means 56 out of 100. That's what 56% means. Well, as soon as I read this out loud, it says its decimal name, okay? 56 hundredths is written as 56 hundredths. Ta-da! So if this is how your brain works, go for it. If DP is how your brain works, go for it. Some kids are great at just moving the decimal point around and they remember that rule. Other kids really need to think about it in terms of what it means to help them through. I'm good with either one. Okay? I didn't even write something. Eat. Let me put my little answer. So it's 56 hundredths and we're moving on. Okay. So that's one type of problem. Again, if you're not comfortable with it, ask for try another, right? So on this one, it is asking you to take a fraction and turn it into a percent. Okay. So I always say when we talk about percents, it's always out of 100, right? So how can you get 5 to turn into 100? Okay. If you don't know that, you can check your fact chart. But technically, hopefully by now we're starting to remember 5 times 20 will get you 100. So whatever you do to the bottom, you have to do to the top. And that gets you 80. Okay. Any number over 100 is the actual percentage. Oops, derpy. Okay. So that means my answer is 80%. And lovely, they do just give you this little percent sign. I like the fact that they do that because it's just trying to remind you that, hey, this is a percent answer. So, anywho. So again, just make sure that your denominator is out of 100. That's a great way to remember it. Here we go, moving right along. Okay, so now we have a decimal and we want to turn it into a percent. So again, DP, right? If you remember that from our notes. If we're going from a decimal to a percent, which we are, it means we're moving twice to the right, okay? So if I have 12 hundredths and I go twice to the right, It's just sitting right here, which gives me a whole number. That means it's 12%, right? Or if your brain doesn't work like that, you can say, I'm going to read this out loud. 12 hundredths. Wow. Any number over 100 is the percent. So logically, I just created a percent. So again, your brain may work this way. It may work this way. Either way, very cool. Love hearing how your brain works. It's very cool. Okay, so 12%. Moving on, or try another if you would like. Is over of questions. You do have 4 of these on your test, and they're in all different formats. Okay, so again, we have is over of equals percent over 100, right? Or percent out of 100. Okay. The only things that you are trying to fill in are your percent sign, your is, and your of, right? 100 always stays there. Okay. So the first thing I notice, what number is 35% of 40? So I know for sure, I always say look for your percent because it's the easiest to find. I mean, it literally is the number that has a percent sign attached to it. So I'm going to put 35 there because that is obviously my percent. And the only word next to 40 is of. So I'm going to put that in my of spot, right? Cool. So that means my is my what, right? And in math, instead of saying what, we put a variable. I always use X. It's just my thing. Okay. So step 1, you fill in your formula, correct? Step 2, you cross multiply. I always start with my variable. So on this, it's 100 times X. We can't actually solve that because we don't know what X is, right? So I'm just going to write 100 times X. The other direction, I'm going to take 40 times 35. And if you're like, oh my gosh, please don't take an hour to do it by hand, right? That's not what we're testing. So 40 times 35 equals 1,400. Okay. So 1,400. So we've done our cross multiplication. Now the only thing you have left to do is to isolate your variable. Okay. In fancy terms, isolate your variable by doing the inverse operation. Basically, you want to get this guy all by itself and get rid of this by doing the opposite. So right now we're multiplying by 100. So I need to do the opposite, which is dividing. Okay. So it's not all, the rule isn't to divide both sides by 100 every single time. The rule is to do the opposite of whatever number this is. So if this number was 40, you'd be dividing by 40. Okay. So I'm going to divide both sides because you have to be equal. It's an equation. Whatever you do to one side, you have to do to the other. Now, how does this get X by itself? You should know by now, but we've gone over this. 100 over 100 is the same thing as 1. If you eat 100 slices out of 100 slices, you ate the whole pizza, right? Well, if this is 1, that means you're left with 1x or 1x. Cool. And then 1,400 divided by 100 gets me the number 14. Now, before I just plop that in there, I'm going to check, does that actually make sense? 14. Does that seem like it could be 35% of 40? Well, let's see here. 50% of 40 or half of 40 is 20. So it makes sense for me to think of 35%. It's definitely less than 50, right? And 14 is definitely less than 20. So logically, it makes sense. Okay. I'm going to go through and just do one more of these. I'm pretty sure I gave you multiples, but I'm just going to do one because I know it takes a while to explain. So on here, I like this one because we have our is over of. And percent out of 100, right? If you look at this example, it says, what percent of 68 is 17? So I always say look for the percent sign first. There is none. So that automatically tells me my variable goes there. I have no percent sign there, right? So I automatically know, that's my goal. I'm trying to find the percent. What percent of 68 is 17? Well, let's look. My of 68, 68 is 17, right? So my is now my 17. Okay. So now your next step is to just cross multiply, right? You plugged in, now cross multiply. Again, I always start with my variable. So I can't actually solve 68 times x because I don't know what it is, right? I don't know what x is, but I can write 68 times x, right? And then the other direction, when I cross multiply, 17 times 100 is 1,700. Okay, I just took my 17 and plop on those two zeros. That's my little shortcut. And your very last step is to isolate your variable, right? So we need to isolate it. We need to get it by itself. So how do I get x by itself? I'm going to do the inverse operation, the opposite. Right now I'm multiplying by 68, so I need to divide by 68. And whatever you do to one side, you have to do to the other, right? So this leaves me with 1x or 1x. And then again, please, for the love of God, do not go through and try to solve this by hand. I love you and I love your effort, but you don't have time for that, right? So instead, you're going to actually type in 1,700 divided by 68. Work smarter, not harder, right? So our answer is 25, right? And again, let's go through and say, does that make sense? 68, 25% of 68 is 17. Basically, 25% means if I took 68 and I divided it into 4 chunks, right? Would that be about 17? I think that's about right? Because I'm thinking 17, I could round that to 20. So I could say 20, 40, 60, and I'm a little off from 68 for that fourth person or for that fourth part. Okay. So in general, it makes sense. Okay. So like I said, oops, do not write your answer. You did not write your answer as a percentage. My bad. Okay. So it's 25%. I love it. Okay. Thanks for the help, Alex. Okay. So let's go through and I'm going to clear my screen. Continue. Again, if you want more, please push it. Try another. I'm not going to because of time. All right, now we're going to go through and we're actually going to convert. Brain fart. Okay, so we're going to convert. Again, this one should be pretty clear in your head right now because it's literally the last lesson that we just did, right? So I'm trying to come up with 9 yards equals how many feet, right? So yards and feet. These are my conversion chart measurements right here. So I'm going to look at my chart. What's my conversion rate? It says that for every 1 yard, that is the same thing or equal to 3 feet, right? So the first thing you do, fill in your chart information, right? The second thing you do is fill in the junk from the question, right? What are they asking me? Okay. I know 9 yards. Yards was designated to go on top. Again, if you flipped it, it doesn't matter. Just be consistent, right? If you put yards in one spot, it has to go in the other. Okay. So 9 yards they gave me. I don't know feet. So remember, if you don't know something, your what becomes a variable. That's my x. Okay. And again, this is exactly like what we just did. So it's our is over of type of format. Meaning I can go through and I can now cross multiply. I'm going to start with my variable. Oh, this is lovely. X times 1 is 1x. And 9 times 3 is 27. Sweet. Okay, so my answer is 27 feet. Cool. So I'm going to just put 27 here. I just like to point this out. Inside your head, you may have been able to just go, okay, so 9 yards. If 1 yard's 3 feet and I need 9 yards, I'm just going to multiply by 9. That's awesome. I love it. That means that you have common math sense. Okay, go for it. On your test, all you have to do off to the side is write 9 times 3, to show your work, and then put it here. Okay. But for those of you who are like, I don't really understand what's going on, use this formula to help you, because it's a method you're familiar with, and it's very cookie cutter, right? So either way that you want to work or can work, I'm not going to force you to do it this way if you can very easily see that you're just multiplying by 9. Just know on your test you have to write 9 times 3 to show me how you got 27. Okay. And then for the next one, it's going to be the exact same method. So for the next one, we're comparing inches and feet, right? So your inches and feet's right here. So my chart method, or my chart conversion rate, is what I fill out first. I'm telling myself for every foot, that's the same thing. It's equal to 12 inches, which we should know. A ruler is a foot, and there's 12 inches on a ruler. Okay, so my chart is filled out. This is my conversion rate. And then whatever's in my question is what comes up next, right? So 24 inches, I know that. So I'm going to put 24 on the bottom because the bottom is designated for inches. And then I don't know the feet, right? That's what we're looking for. So when you don't know something in math, you got your what variable. Okay. So now I'm ready to cross multiply. Cool. So when I cross multiply, I end up with 12 times x. Don't know what that is, so I can't solve it. So it just sits there, 12 times x. And then cross multiply the other way, 24 times 1 is 24, right? Isolate my variable by doing the inverse operation. Get rid of whatever's attached. Get rid of your coefficient. Okay, get rid of what's attached to your variable by doing the opposite operation. So if I'm multiplying by 12, I need to divide by 12. So that leaves me with 1x. Whatever you do to one side, you have to do to the other. 24 divided by 12 equals 2. Cool. So here we go. I'm pretty sure that the rest are going to be similar to this. I'm going to just kind of fast forward a little bit just to make sure. Yep. So the rest are still conversion problems. Some of them may be word problems. Okay. It's the exact same thing. So you're given something, right? So this is what you're given. You're given 72 square inches, right? And right? And you're looking for square centimeters, right? So we have square inches and we're looking to convert it to square centimeters, right? And then you're given a conversion rate. And I just derped right over it. Okay. Anyway, it's the exact same setup, you guys. So you're still looking at there's no chart, right? But I'm going to still label it chart because this is your conversion rate. What's your conversion rate? 1 square inch, and we haven't really gone over this yet, but this is square inch. When you square something, it's to the second power. Okay, 1 square inch is equal to 6.5 or 6 5/10 square centimeters. Centimeters squared is with your power of 2. Okay, so that's what they gave me. Filled it out. Now in my problem, what am I being asked? I have 72 square inches, so I'm going to put 72 on top because that's where I designated my square inches to go, right? Inches squared. I don't know the centimeters. That's what I'm looking for. So again, all you're doing is cross multiplying, right? So 1 times x, 1x. And you're literally left with just multiplying to find your answer. So I'm going to go over here and I'm going to take my 72 and I'm going to multiply it by 6 5/10. And I get 468. So 468, whoopsies, 468 centimeters squared is already there for us, so we don't even have to type in our units. Cool. So anywho, I just wanted to point out, yeah, it's not a chart, but you're still using it in the same way if you want. Okay. So again, ta-da. I hope this helps you. I hope you watch it, pause it, fast forward it, rewatch it, whatever you need to do. And that is all I've got.